Okay, so we are starting our topic on data transformations, and it follows on nicely from the topic of linear regression. Okay, so what is data transformation? Data transformation can be used to linearize scatter plots and solve problems with nonlinear associations to make predictions, and making predictions is ultimately what we're trying to do when we create a line of best fit. And we have some different types of transformations, so we're going to look at all of them one by one. We've got squared transformations, logarithmic transformations, and the reciprocal transformation. And all of these transformations can be done on either the x or the y axis. And in a little while, we'll have a look at how we would decide which one to use. But before we do that, I just wanted to show you just a little example to just show you how powerful this is. So I've already started a document here, and in my document I have some x values in this column and some y values in this column. And if I was to graph them for you, let's just see if I go Control-I, add data and statistics. So we have our x-axis and our y-axis. And if you have a look at that, it's not really what I'd consider linear. It's sort of got a curved shape. It's trending upwards in one direction, but it's not very linear. Now, if I wanted to do a transformation on the x-axis, this is just a quick example for you before we get into it. I could actually square all this data in this x column. So I come along to here in this box where the equals is, and if I type in equals and I put in, the name of that column x, and I square it and hit enter, tell it I want a variable reference, what it's done is it's actually squared every single value in that x column, okay? So we need to know how to do that first of all when we're doing this with our CAS. Let's go back and have a look at our graph. So as we saw before, this is quite curved, but if I now change this variable to x squared, look at what happens. This has been transformed, it's been linearized, and this is what we're looking at with transformations. Go back to x, and we could actually do a regression analysis on this, and let's see what happens to our, R value, well, our R squared value, but of course our R value is related to that. And here we have 0.90245 with the curve, with the curved one. If we change this to x squared, and look what's happened. Our R squared value is now 0.99.